Good morning, guys. Short video for you today. This is actually the last topic that we have before our first test. All right, so your first test is going to be next week, probably Wednesday, Thursday of next week. All right, so make sure that you are planning and ready for it. We will definitely be talking about it and discussing it as the time gets closer, but now you know a day, okay? I will give you study materials, I'll give you things that you need. This is the last thing that we have for chapter 1. All right, so we're going to talk today about density. And when we talk about and understand density, we will be able to answer this question here. How much stuff is in this much stuff? Okay, and that will hopefully make more sense as we move on. All right, so let's get my computer to work, and here we go. So density is a ratio between mass and volume, and a ratio is always the same. Ratios don't change. Okay, so we can have a 50% ratio. All right, and everybody is kind of familiar with a ratio of 50%. This could be 1/2. 1/2 is also equal to 2/4, which is also equal to 50 over 100. Okay, so this ratio of 50% up here doesn't change no matter what these top and bottom numbers are. The ratio is always going to be 50%, or 1 to 2. There's several different ways that we can write out ratios, but the ratio stays the same. Okay, so this ratio describes how much mass is in a certain space, a certain volume. Okay, so this density is talking about how much mass or how much weight, how much matter is contained within a specific volume. Okay, for your units, you're going to have in any density measurement, you have a mass unit over a volume unit. Okay, a lot of times the units for density is grams per milliliter. Okay, that's very common for density, but sometimes you end up seeing kilograms per liter, or maybe grams per centimeter cubed, or grams per liter. Okay, these are all mass over volume. Okay, and so no matter what these individual units are, as long as we have a mass over a volume, that is an acceptable unit for density. Okay, water has a density of 1. Okay, water is oftentimes going to be our standard to compare things to, and in this case, for density, water has a density of 1.0 grams per milliliter. Anything with a density of more than 1 will sink when it's put into water. Anything with a density of less than 1 will float. Okay, and so usually when we're in class, I hold up that the 1 liter pop bottle that has oil on top and the blue food coloring water on the bottom, and I ask you, does oil have a density greater than or less than 1? And you would answer, it's less than, because it floats on the water, and it's less dense than water, so it does not sink. Okay? The equation to solve for density is D equals M over V, mass over volume. Okay, so D is density, M is mass, V is volume. This is a very simple yet very important equation that we have to be able to remember and understand as we move forward. Okay, this is not going to be the first time or the only time this school year that we talk about density. So we need to be able to remember this. D equals m over v. All right, and a lot of times, while this seems pretty simple and straightforward, the way that the question is going to be formatted and the way that question is worded might not be so simple. Okay, for example, instead of just giving you a number here for volume, you might have to calculate volume. Okay, and it might say that you have a cube that has with each side measuring 3 centimeters, and its mass is this much. What is the density? Okay, so then you would have whatever number the mass is over 3 centimeters times 3 centimeters times 3 centimeters, because this would be how you calculate the volume of a cube with 3 centimeter sides. Okay, so you might have to calculate the volume before you can use this equation. Okay, so that's just something that you should be prepared to do as you get into your homework for density. I'm going to get out of this. No, I don't want to keep those. I'm going to get out of this, and I'm actually going to work through a question with you on your homework that is exactly what I just described. Okay, so we're going to look at number 3 here. We have a block of copper. Okay, this block of copper measures 2 centimeters by 4 centimeters by 5 centimeters. So it's not a cube, it's more of a rectangular shape, and it weighs 356 grams. What is its density? So we are looking for density. We know the mass. Okay, and we can solve for the volume. Remember that the volume of a block or a cube is going to be length times width times height. So I'm going to take 2.00 centimeters times 4.00 centimeters times 5.00 centimeters. 2 times 4 is 8. 8 times 5 is 40. So I have 40.00 centimeters times a centimeter. Sorry guys, my cat is being a jerk. Surprise, surprise. Anyways, centimeter times a centimeter times a centimeter in terms of our unit is going to give us centimeters cubed. Okay, so from there, I can use this D is equal to m over v equation, and I'm going to have 356 grams for my mass over 40.00 centimeters cubed. And I'm going to put that into my calculator. Let me open my calculator. All of my good calculators are at school, so when I'm at home, I have to use my phone. 356 divided by 40, and I get let's just kind of bring this up here. When you guys do this problem, make sure you give yourself enough space on your homework sheet. Density is going to be equal to 8.9 grams per centimeter cubed. And that would be my final answer. You guys can't see my cat. Maybe you can. Here, I'll show her to you. Down here in the corner. She's being a jerk. It's late at night. Everybody in the house is sleeping except for me and the cat. What a jerk. Alright, there's your video over density and an example problem to complete for your homework. Go watch the other video. It's another really good explanation for density. And I'm going to try and take care of this cat. Alright, see you guys later.